Hi learners, now we're going to have radical equations. In this lesson, you are expected to solve equation involving radical equations. Second, recognize extraneous solution. And third, isolate radical term in an equation using rules of radicals. Let us have a review of our previous lessons. What is the principle of powers? The principle of powers states that if an equation A is equal to B is true, then A squared is equal to B squared, or B cubed is equal to B cubed, or A raised to n is equal to B raised to n. How about the zero product property? The zero product property states that if A and B are any real numbers and AB is equal to 0, then either A is equal to 0 or B is equal to 0 or both A and B are equal to 0. How about an extraneous root? An extraneous root is a solution to the equation that seems to be right, but when checked by substitution in the original equation, turns out to be not right. Take note that the equations containing radicals with variables in the radicand are called radical equations. And to solve radical equations, one must first get rid of the radicand in the equation. This can be done by squaring both sides of the equation using the principle of powers, that if A is equal to B, then squaring both sides A squared is equal to B squared. The basis for solving radical equations is to eliminate the radical sign. Let us have the steps in solving equations with radicals. First step, we need to place the radical expression on one side of the equation. Second, raise both sides of the equation to the index power to eliminate the radical. Third, simplify or solve as usual. And lastly, checking. Verify the result discarding those that are extraneous. Examples. Solve the following. Number 1. Square root of x is equal to 12. Since in the equation, the radical is already on one side of the equation, therefore we can proceed to the second step, and that is to raise the equation into the index power. And that index is 2. That means we need to raise both sides of our equation to 2. So therefore, we have quantity square root of x raised to 2 is equal to quantity 12 squared. By applying the laws of radicals and laws of exponents, therefore we have x is equal to 144. Since x is equal to 144, we need to determine whether 144 is a real solution or not. So we are going to substitute 144 to the original equation. Therefore, we have square root of 144 is equal to 12. Square root of 144 is 12. Therefore, the left and right side of our equation are equal. That makes 144 a real solution. Next, square root of x minus 3 is equal to 6. The radical expression is already isolated on one side of the equation, so just like in number 1, we need to square both sides of the equation to eliminate the radical sign. So therefore, we have the square root of x minus 3 is equal to, therefore we have quantity square root of x minus 3 raised to 2 is equal to 6 squared. So therefore, we have x minus 3 is equal to 36. X minus 3 is equal to 36. Therefore, solving for x, we have x is equal to 36 plus 3. Therefore, x is equal to 39. So we check whether 39 is a real solution or not by replacing it to the original equation. So we have 39 minus 3. Square root of 39 minus 3 is equal to 6. Square root of 39 minus 3 is square root of 36. So the square root of 36 is 6. So the left and right side of the equations are equal. So therefore, x is equal to 39 is a real solution. Next, we have 4 plus the square root of x minus 2 is equal to x. Since the radical equation is not alone in one side of the equation, we need to isolate it. So we need to transpose 4 to the other side of the equation so that the square root of x minus 2 is left on one side of the equation. Therefore, we have the square root of x minus 2 is equal to x minus 4. Take note that when you transpose a term from one side of the equation to another side, you need to change the sign. So next, we need to raise both sides of the equation by 2. So therefore, we have quantity square root of x minus 2 square is equal to quantity x minus 4 square. So by applying the laws of radicals and laws of exponents, therefore, we have x minus 2 is equal to x squared minus 8x plus 16. Combining all similar terms, therefore, we have 0 is equal to x squared minus 8x plus 16 minus x plus 2. We have the quadratic equation 0 is equal to x squared minus 9x plus 18. Since we have a quadratic equation, we can make use of the methods of solving quadratic equation in order for us to solve for the value of x. So since the quadratic equation is factorable, we make use of the factoring method. So the factors of our quadratic equation are x minus 3 and x minus 6. So therefore, we have 0 is equal to quantity x minus 3 times quantity x minus 6. Applying the zero product property, therefore, we have x minus 3 is equal to 0. Therefore, the first value of x is 3. Next factor, x minus 6 is equal to 0. Therefore, we have the second value for x, which is 6. Take note that it is necessary to check the solution if it satisfies the original equation for all radical equations to determine if there is any extraneous root. For example, in example number 3, x is equal to 3 is an extraneous root, while x minus 6 is the only solution in the radical equation 4 plus the square root of x minus 2 is equal to x. Why? Let us have our proof. If x is equal to 3, we are going to replace 3 to the x in the original equation. Therefore, we have 4 plus the square root of 3 minus 2 is equal to 3, simplifying the radicand. Therefore, we have 4 plus the square root of 1 is equal to 3. The square root of 1 is 1, so therefore, we have 4 plus 1 is equal to 3. And 4 plus 1 is not equal to 3, rather it is 5. So that makes 3 an extraneous solution. Next, if x is equal to 6. So we are going to replace 6 with all the x's in the original equation. So we have 4 plus the square root of 6 minus 2 is equal to 6. Simplifying the radicand, we have 4 plus the square root of 4 is equal to 6. Therefore, we have 4 plus 2 is equal to 6, and 4 plus 2 is equal to 6, and 6 is equal to 6. That makes 6 the only solution in the given radical equation. 4 plus the square root of x minus 2 is equal to x. In case more than one radical appears in the equation, we need to isolate one radical on the left side, then square both sides. We continue to do this until no radical can be found in the equation. For example, we have to solve for x in the square root of 2x plus 1 minus the square root of x minus 3 is equal to 2. Since there are two radical equations in the given equation, we need to isolate one of the radical equations. So, we have the square root of 2x plus 1 is equal to 2 plus the square root of x minus 3. We square both sides by applying the laws of radicals and laws of exponents. We have 2x plus 1 is equal to 4 plus 2 square root of x minus 3 plus 2 square root of x minus 3 plus the square of the square root of x minus 3. Simplifying further by combining the similar terms, therefore we have x is equal to 4 square root of x minus 3. Since the equation is still a radical equation, we need to square both sides of the equation. So therefore, we have x squared is equal to 16 times quantity x minus 3. Simplifying it further, we have x squared is equal to 16x minus 48, which leads us to quadratic equation. X squared minus 16x plus 48 is equal to 0. Since the quadratic equation is factorable, we make use of the factoring method in solving for the quadratic equation. Note that we are not limited in using factoring method in solving for the value of x in this equation. If you want to make use of quadratic formula or completing square, you can do so. But in this case, it is much convenient for us if we make use of the factoring method. So the factors of the quadratic expressions are x minus 4 times x minus 12 is equal to 0. Applying the ZPP or the zero product property, we have x minus 4 is equal to 0. Therefore, the first value of x is 4. X minus 12 is equal to 0. Therefore, the second value of x is 12. To determine whether 4 and 12 are both solutions, we need to replace 4 and 12 to the original equation. Determine whether 4 and 12 are real solutions of the equation, we need to substitute 4 and 12 to the original equation. If x is equal to 4, we substitute 4 to the x's. So we have the square root of 2 times 4 plus 1 minus the square root of 4 minus 3 is equal to 2. So we have the square root of 2 times 4 is 8 plus 1 is 9. So the square root of 9 is 3. Minus the square root of 4 minus 3 is 1. And the square root of 1 is 1. 3 minus 1 is equal to 2. So therefore, x is equal to 4 is a real solution. Next, if we have x is equal to 12. So we are going to replace 12 on the x on the original equation. So we have the square root of 2 times 12 plus 1 is the square root of 25, which is equal to 5. Minus the square root of 12 minus 3 is the square root of 9, which is equal to 3. 5 minus 3 is equal to 2. So therefore, x is equal to 12 is also a solution of the equation. So in this equation, there are two possible solutions. We have 4 and 12. Now let us come to the activity. To answer the activity, pause this video to give you an ample time in solving the equations. Once you are done, you can play to verify your answers. Let us check your answer. Number 1, square root of x is equal to 4. The value of x is 16. Number 2, the square root of 2x plus 7 is equal to 5. The value of x is 9. Number 3, the square root of x minus 5 is equal to 0. The value of x is 25. Number 4, the square root of x minus 1 is equal to x minus 7. The value of x is 10. And lastly, number 5, the square root of 2x plus 1 minus the square root of x plus 8 is equal to 0. The value of x is 7. It is the only solution for the given radical equation. Get the answers correctly? If yes, very good. But if not, do not worry, because you can play this video until such time that you can get all the correct answers. That's all for today. Thank you and God bless. Happy learning!